Hello everyone, so in this last respiratory system lecture video, I will be talking about, in this case, respiratory volumes, okay, and capacities in this case. So we actually have two types of names here, volumes and capacities. Capacities are the sum of two different volumes, two or more different volumes, and volumes in this case is just basically just one measurement. So this is a normal spirograph. So a spirograph means to say it's a graph indicating how much air is being moved in and out of the lungs, okay, per unit time. So normally this is time, normally this is volume, okay. And what happens is you actually have this multiple like squiggles and valleys and peaks here. And all you have to think about are peaks are always, in this case, inspiratory volumes, or making sure it's the amount of air that you can move in, and any downward values are actually things that you can exhale. So this little volume here, which is approximately 500 mils for both male and female, is called tidal volume. And tidal volume is the amount of air that is moved in and out during normal breathing. So normal breathing, quiet breathing, 500 mils. Okay? If you, and you can do this at home actually. So what happens is if you just breathe in and out, and what happens is you exhale 500 mils just regularly. Inhale, or like in this case, and then take a big inhalation. What happens is we have this thing called inspiratory reserve volume. And the reason why it's called reserve volume is because it is the amount of air that can be inhaled in addition to the tidal volume. Tidal volume, by the way, is mandatory. Inspiratory reserve volume is not. Okay, so this is abnormal, but this is again just a measurement of how good your lungs are in this case. Okay, so that is actually, so that is again how much air you can actually inhale in on top of the normal air that you can actually breathe in and out. And then obviously on the opposite thing, if you do normal breathing, and then what you do is you exhale as forcefully as you can, what happens then is what we have this thing called expiratory reserve volume, which is the amount of air that you can exhale in addition to tidal volume. Okay, and these are approximate volumes. Okay, so this is actually around 1200 mils here, so that's actually around 1400 mils or so. So that is actually again just some basic volumes. And then residual volume, there is always going to be volume left behind in the lungs. The lungs will never completely deflate. So that leftover volume that is always going to be in the lungs, which cannot be directly measured, it can only be mathematically calculated, is called the residual volume. Okay, so this three you can measure. Tidal volume you can measure. There's actually this thing called spirometer. Inspiratory reserve volume you can measure, expiratory reserve volume you can measure, but residual volume you have to extrapolate in this case. Now when you do some additions here, if you take the volume that you can move in and out normally plus the inspiratory reserve volume, that's called the inspiratory capacity. Again, capacity means it's the sum of two or more. Okay, then if you look at this one, the vital capacity is actually all three volumes, three measurable volumes added together. That means inspiratory IRV, TV, and ERV. And then the residual volume, that means how much air can always be left over in the lungs. That's actually this called functional residual capacity. And then the total lung capacity is again all of these volumes added together: residual volume, expiratory reserve volume, tidal volume, and inspiratory reserve volume. Okay, the next slide actually shows you normal values for men and women. As you can see, tidal volume and residual volume is approximately almost the same between males and females, and these are averages. Okay, that just because you have small tidal volume and so on and so forth doesn't mean that you're actually abnormal. And it also has something to do with height, okay, and being fit. These volumes are actually higher if you are taller, if you are more fit, and if you live in a high altitude. So if you live in Colorado for a long time, let's say in, I don't know, Denver, or somewhere even higher like the Himalayas, your actual volumes are actually gonna be more than normal. Okay, obviously if you're smaller, if you're I don't mean smaller, but like shorter, if you're obese if you live in lower elevations, you're going to have lower capacities here. Now, some mental notes here. You can actually they can actually diagnose what kind of disorder you have based on a lot of these volumes. And these volumes, which is actually not quite functional, there's actually two other volumes and capacities that they actually measure, and they do it by measure of time. There's actually a thing that's called forced expiratory volume, which is the amount of air that you can actually breathe out, and normally it's indicated by 1 at the end, which means it's measured in 1 second. And then the inverse of that is actually called forced vital capacity. Okay, so that's actually the inspiratory capacity in this case, and that's again done by unit of time. So you can actually have what actually happens is the total, if you think about it, the total lung capacity is constant. Okay, 6,000 mils, 4,200 mils for females. If one of these values is small, let's say the inspiratory capacity is smaller, it's still going to be 6,000 mils. So some of those volume is going to be transferred to functional residual capacity. Okay. Or to vital, not vital capacity, okay? So if vital capacity becomes shorter, becomes smaller, what happens is primarily speaking is you might have a bigger residual volume. So this is the normal distribution. Again, if this number becomes bigger, these two numbers are going to become smaller, or only one of them is going to become smaller. If this number becomes smaller, then more than likely one or two of these numbers is going to become smaller, but this volume is going to remain constant. Yeah, this is a very important thing about lung volumes in this case. Okay, there are also when you actually work out, specifically speaking, this is actually like how you actually can see this. Your tidal volume increases. Okay, so your breathing is no longer 500 mils; it's going to be like 1,000 mils. What happens is, since this number increases, your inspiratory reserve volume and your expiratory reserve volume becomes less. Okay, so think about it, right? If you're huffing and puffing heavily because you just went on a 5-mile run, you are not able to exhale as much or inhale as much extra at the end. Okay, so but remember, your total lung capacity still remains the same. There's also two main types of respiratory problems. We actually have what we call restrictive problems. And restrictive problems is primarily caused, in this case, by the inability, in this case, to actually inhale, okay? And actually, in this case, exhale as well, right? So there's problem with your respiratory muscles, there's problem with your lungs inflating properly, okay? And what happens is restrictive, basically what that means is restrictive basically means to say is there's an obstruction, okay? So restriction and and obstructive. So in restrictive, what happens is your pathways, your actual passageways are actually smaller than normal. Asthma is actually a restrictive problem. Okay, COPD, obviously by the word O, is actually an obstructive problem. Okay, so restrictive, okay, obstructive, so all of that stuff. So that's actually two main types of respiratory problems. Okay, so if someone breaks your rib, okay, obviously inhaling and exhaling is going to be painful, so your respiratory volume is going to decrease. Okay, but if you have a problem with your passageway, what happens is the amount of air that you actually move in and out is actually not affected, but what happens is it takes you longer in restrictive problems. It takes you longer to move the 6,000 mils or the 4,200 mils. So the volumes in restrictive problems normally does not decrease. Okay, it's the ability to move it, the volumes, is actually affected. In obstructive, this volumes actually becomes smaller. So this is one of the big main hallmarks of restrictive versus obstructive pulmonary disorder.